Hi everyone, welcome back. I can't believe we are already in the final stretch, just 2 more sessions left after all the ground we have covered this semester. Today's focus is SQL multiple table review and project suggestions. This session is designed to help you to consolidate everything we have learned about working with the multiple tables and to inspire you as you prepare your final projects. We'll begin with a quick review of key concepts, joins from key subqueries, and how to pull insights from across related datasets. These are the bread and butters of a real-world SQL. Then we'll pivot to project mode. I'll walk you through a few project ideas, and then you will have time to start shaping your own. The goal is to leave today with a clear direction and some momentum heading to our last class. Let's make this final sessions count. Ready to dive in? Let's review union and renaming columns. Union let us combine rows from multiple tables with the same column structure. Renaming column using as is optional, but helpful for clarity, especially if you are using order by at the end. Just remember, the final column's name comes from the first select, so if you want clean, readable output, rename upfront. This example shows how to combine data from both student and faculty table into one directory using union. First, concatenate first and last name to create a full name. Second, rename the column into both selects match. And then we add a member label, faculty or student, to track the source. Finally, we order the results by member type, last name, and first name. This is a great pattern where you want unified view from structured different table. Now comes to inner join, which is connecting two tables where keys match. In this case, we're joining faculty and student on the advisory relationship. Faculty ID equals student's advisor. We're also formatting names using string concatenation and using alias like as student and as advisor to label columns. Just note some DBMS may not accept as student, so we might rename it something else like advisee. The results will give us a clean list of students with their advisors sorted by advisor and student name. In addition to inner join on, we can also use another where clause. This is an older but still valid approach. Instead of writing inner join on, you list both tables in the from clause and use where to match keys like where table 1 ID equals table 2 ID. This works the same as inner join, but syntax is less clean. Some developers still prefer it for quick joins, but for clarity, join on is more modern style. This is a working example using where to join two tables, faculty and student. Instead of using inner join, we list both tables in the from clause and join them with the where faculty ID equals to student advisor. We also formatted outputs with the full name and aligned like advisee and advisor, then sort the results using order by. Functionally, it works same as inner join, just using an older syntax. This example shows how to join more than two tables, a common real-world task. Here we are combining student enrollment and class table. First, we join class and enrollment on CRN. Then we wrap that in a brace that join to student using student ID. The key is to break it down step by step, joining two tables at a time using lines like S, C, and E, make the query easier to read. In addition, the braces are not strictly required in this query, but they help to clarify the join order. In addition to inner join, there can also be left join or right join. In this example, this helps us to answer a real-world question. Which faculty member don't have any student assigned? We join faculty to student on advisor ID, but kept all faculties with the left join. Then we filter where student ID is null, meaning no student match that faculty member. The results give us a list of faculty without any assigned student. This is a classic use case for left join plus is null. Similarly, the right join helps us to find students who don't have an advisor. We join faculty to student on advisor ID, keeping all students from the right table. Then we filter where faculty ID is null, meaning that student advisor ID didn't match with any faculty. This is just the measure of the previous left join example, same logic, just flipped perspective. This slide shows how to build a left join visually in the Microsoft Access using Query Design View. We're joining faculty to section on the instructor field and including all faculty even if they didn't teach a section. Note the join line with the arrow is set to include all the records from faculty and only matching ones from section. Then in the criteria row, we filter where section course number is null, which tells us which faculty did not teach any course. This is a great example using Access Visual Tool to create outer join without writing SQL manually. So in Lab 1, it will give you a solid starting point. Like later on, you can use my feedback to refine if it's needed. For the project part 1, it focuses on modeling. Please clearly state the business needs and rules driving your design. They include ERD, you can use Access for that. And then build a data dictionary showing data table structures, attributes, types, size, and constraints. Finally, check normalization. Ensure that your table are in 3NF and explain why if not. This modeling step sets the foundation for your final project, so take time to get it clean and logical. So this is an example of the relationship diagram of one of the database. So this will, make sure your ERD clearly reflect this key relationship. For example, here, student links to faculty via advisor, and to enrollment, registration, and a zip. Enrollment bridge student in a class, and a class links to course. And also like a registration connected to registration detail, which capture course actions. So please create like similar things for your own database. As you finalize your project, double check for proper primary foreign key links, no often tables, and also clear cardinality if that's a one-to-one, one-to-many, or many-to-many. Keep this like this kind of map. This is the foundation for your SQL logic. So the four main components you need to include in your final project submission. The number one will be modeling. That will define the business needs and rules that shape your database. And the number two will be the ERD. So please submit a clear entity relationship diagram either from Access or drawing tool. And then we have a relational model showing table structure, keys, and relations. And finally, have the dictionary, including field names, data types, constraints, and descriptions. Each part builds on the others, so please be sure that your documentation is clean, complete, and aligned with your actual database design. Just a quick reminder, you're not alone as you wrap up your project. You can always email me if you get stuck or need clarification. I'm available for project support, whether it's SQL, modeling, or formatting your dictionary. Let's finish strong and use the support available to you. As you finalize your project, keep this database best practice in mind. Number one, normalization. Help to eliminate redundancy and keep your data clean. Aim for 3NF unless there is a reason not to do so. Number two, indexing. Improve query performance, especially on frequent searched column. Constraints like not now, unique, and foreign key protect data integrity. And finally, documentation. Ensure that your design is understandable and maintainable. That is where your data dictionary really shines. Good design now saves headaches later. As we wrap up this session, I encourage you to keep building your SQL skills beyond this course. Whether you are heading into analytics, engineering, or database management, SQL will stay relevant. Here are 4 great next steps. Number 1, advanced queries. Practice joins. And also one thing called window functions. I know I didn't teach that window functions here, but you can definitely find source online. And also CTEs and more. There is a great resource for you to practice. It's called LeetCode. They have sections for SQL problem, which provide you a lot of real-world style challenge to sharpen your skills. To be honest, even myself, like if you want to have another interview or whatever, people always come to this LeetCode. They also have Python, C++, different language practice problem. And then like for SQL, we always prepare over there before we go to any interview. And number 2 is database administration. Learn how to manage your database user and backups. And also, we need to learn about performance tuning. Understand how to optimize slow queries using index and explain plans. Finally, big data integration. Explore SQL with modern platforms like Spark SQL, AWS, Athena, or Google BigQuery. Even though those are slightly different, like if at Microsoft we even have something called Custo, where we use KQL. Even if all those syntax are a little bit different, but they kind of similar, especially if you can use ChatGPT to help you to convert between the different types of SQL or even convert to Python. Like ChatGPT can do a wonderful job for you. And also keep practicing, and if you ever get stuck or curious, I'm always happy to recommend paths forward. Again, so I think the great source that I have is LeetCode, where you can prepare for specific interviews. And also ChatGPT is just so powerful. Even if you just said, okay, I want to write a SQL for this kind of situation, it will create a SQL for you. And if you said, okay, I want to convert this to Python, it can convert that to Python as well. So just leverage the AI source right now. I just feel like nowadays you're just at a much, much better and easier time to learn any new things. Anyway, so we'll wrap up this class, and I will see you next time.